If the first term of a series is 6 and the second term is 2, and if the series is an arithmetic progression, then let's find the sum of the first 80 terms. If a sequence is an arithmetic progression, then that means that the difference between every two terms will be exactly the same. For example, how do we get from 6 to 2? Well, we must minus 4. And it means that the next term and the next term and the next term will all be minusing 4 every single time. Arithmetic sequence is the same as a linear sequence. If we know we're minusing 4 each time, then this tells us in the formula Sn what the value for d is. So I'll just remind you of that formula. N over 2, 2a plus n minus 1d. N is the number of terms we want. We want 80 according to the question. A is the starting term. This is 6, again, given in the question. N minus 1 will be 79. And d is that difference I was talking about, which is going to be minus 4. Make sure it's minus 4 and not positive 4 because it is going down. Now it's a case of working this all out. So not the nicest of answers, but this will get you 3 marks. On to part 2. So for the same series, which starts 6 and then 2, now we are imagining it's a geometric progression, and we need to find the sum to infinity. So it's the same idea, but this time we are timesing or dividing, depending on what we're doing, from one term to the next. So if we divide by 3, then we divide by 3 again, and again, and again, and again. We're looking for S infinity. And again, if I remind you of that formula, it's going to be A over 1 minus R. A is same as before from part A, part I, is the first term, so it's going to be 6. But the R is actually going to be the common ratio, so I'll probably want to change this into a times. So timesing by a third, timesing by a third, that means R is equal to 1/3. So 6 over 1 minus a third. 1 minus a third is 2/3. Bring the 3 to the top. 18 divided by 2, 9 is our final answer. Here are 2 more to try.